Good day everyone, and welcome back to DX Explorer for another video. I am back with a Pititico 2. I promised this video, but it's not the main subject for today. The main subject for today, it's mainly for beginners, and it's about the importance of dummy loads when testing transmitters and transceivers, and also the importance of low pass filters, band pass filters, or high pass filters, depending on the project you're working on. So yeah, well, since I received my PCB board from PCBWay, I'm just going to transfer the components from the prototype transceiver into the final version, and I put the parts just a little bit wider on the board. I was asked by some elderly people so they can also install the components very easy, and of course we respect elderly people, so I did that. And yeah, talking about my friends at PCBWay, let's watch a quick promo clip for the sponsor of today's video, and after that we'll be back with a finished CW transceiver and see how it works. Are you tired of making homemade PCB boards that don't always come out the way you imagine them to be? Right now you have PCBWay. With excellent PCB prototyping services, all you have to do is to open your account on PCBWay, use the software of your choice to design your PCB board, upload the Gerber files and place your order. Soon you'll end up with professional and excellent looking PCB boards for your projects. PCBWay also offers PCB assembly services, SMD stencils, CNC, 3D printing and even more. PCBWay is the way. Alright boys and girls, I'm back with the finished Pititico 2. If you got to watch the older video, the original one where I built the prototype of the Pititico 2 on the older board, the homemade one, you can tell it's a big difference. That's why I love these PCB boards. So I was talking, if you didn't get to watch that one, you can watch it after this video, but I was talking about increasing the power output by making little changes, and one of them was to replace the R2 resistor with a 500 milliwatts instead of a quarter watt resistor, and I tuned the output low pass filter a little bit better, and well, I believe I changed, I can't remember, I need to double check with the schematic, but I think I changed this filter to, it's a modified pi network filter that acts like a bandpass filter. But anyway, I tuned this one properly, so right now I'm getting nearly 1 watt power output. I believe that I will slow down a little bit, and I'm going to go back and replace this one to a quarter watt resistor, just because I would like to have a little bit less power, so I don't force the transistor, which I believe it's going to burn very quick if I overheat it so often. But anyway, this is it. I'm just going to connect it really quick to the dummy load and to the power, and let me zoom out. Okay, so I zoomed out a little bit, and now I'm just going to use this dummy load as a key. There you go, 900 and something milliwatts, nearly 1 watt. But the disadvantage when you are forcing the transistor is that it won't be so stable in frequency anymore, and it has the tendency to rise up in frequency a little bit while transmitting, as the transistor is overheating. So yeah, the idea for me is to keep it somewhere around 700 milliwatts if it's possible. Alright, now let's talk a little bit about the importance of a dummy load when testing transceivers or transmitters, any of them, doesn't matter. The idea is that, of course, you will pick the dummy load that will handle the power of your transmitter or your transceiver. So for example, for simple things like the Pititico or the Pixie, which don't have more than 1 watt, I have this tiny dummy load, with homemade dummy load. This is a pen cap actually that I cut it. And over here there's a resistor. It's a 1 watt resistor, 50 ohms. And I soldered it straight to the BNC connector. And basically I'm just connecting this one to the antenna output of the transceiver or transmitter, depends what I'm testing. And that's the dummy load. Of course you can do things a little bit more fancy. So this one is a dummy load from my friends at Drawwaves. It's a 25 watts dummy load, perfect for QRP. Over here you have 2 points where you can actually measure the voltage output of your transmitter, and with the formula that it's available here on the dummy load you can actually calculate the peak-to-peak power output. And the same thing, it's here. It's based on the same principle, except that it will transform your power output straight into a meter, and you will see the power output. You have this one on the DX Explorer blog, and there's a video about this one as well. So this is how it looks like. This one, the resistor can handle actually 250 watts of power output, but I'm not going to use that one. I just use this one for convenience. It doesn't warm up, and I can test very well. I have 2 scales, up to 1 watt and up to 10 watts, from 0 to 10 watts and from 0 to 1 watt. So yeah, it's very important to use this kind of dummy load. I know a lot of beginners. I actually had a couple of them writing to me, and they told me all sort of strange things, and one of them was that I think Roy told me that he can hear the transceiver from 3 kilometers away connected into a dummy load. Now I don't know how is that possible, because for example, if I connect the Pititico 2 into this kind of dummy load and I transmit with the transceiver close by to the receiver, I'm able to hear it. But as soon as I move this one away in the other side of the room, I'm not hearing it anymore. So there's something wrong over there if you can still hear it from 3 kilometers away connected to a dummy load. Now I know in the past I had a couple of subscribers telling me that oh, I've been testing my Pixie. This is from the time when I was working on the Pixie, and they said I was testing my Pixie in a 5 meters dummy load. And I said, what is a 5 meters dummy load? So they connected the 5 meters wire as a dummy load. That is not a dummy load, that's already an antenna. So it's a big difference. So basically a dummy load, it's a 50 ohms resistor which imitates, to say like that, the output of the antenna, because we have 50 ohms. And of course, again, the resistors, they must handle the power output of your tested equipment. Okay, so Roy, if you connected the transceiver into a dummy load, it should not output anything 3 kilometers away from your receiver, from your antenna. So yeah, if I move it 4 meters away from the receiver, I receive nothing in here. And yeah, I won't test it now because it's very complicated. But, or maybe I'll put something at the end of the video so you'll be able to see. But yeah, it's very, very important to have a proper dummy load, not a 5 meters of wire or 3 meters of wire that will act as a dummy load. Again, that's already an antenna. So okay, let's leave this one away now. And let's talk a little bit about the filters. So depending on the project, for example, on a receiver you might have a high pass filter or a low pass filter or a band pass filter, depending on the situation and the bands you're listening to and the bands you're trying to get rid of on receive. In transmitters and transceivers, usually you will find the low pass filter. In my case over here, just because I tried to get rid of the AM broadcast band interferences, is a modified low pass Pi network filter. So basically a modified low pass filter that acts like a band pass filter. But in principle is a low pass filter. Okay, so let's move on a piece of paper, and this is my analog oscilloscope. Let's say here we have the oscilloscope, which I don't have. I would have to save some money and buy some sort of tiny SA or something until I have a proper budget for a proper oscilloscope, or anyway. So let's say here we have 7.2 megahertz, right? Because this is the crystal that I'm using for my transceiver. Now when I'm transmitting, the fundamental frequency will go over here. All right, we reach one point. With a properly made low pass filter, this one over here on the output, properly calculated for the particular frequency that you are using, you will have, here is 7.2, I believe it will be 14.4 because it's double, 14.4. I hope I'm not mistaken, but I'm sleepy, I just woke up. You will have another peak over here, and this one I can't remember, was like minus 40 dB that it has to be to respect the regulations, I believe, for CW and QRP. I think for QRP it might be a little bit more, but I'm not sure, but it's just an idea, right? So this one has to be minus 40 dB, and then you have the third harmonic. This one has to be also lower. Maybe this one will be minus 50 dB. I'm just going to give an example, right? So you keep calculating like 7.2 plus 7.2 plus 7.2 plus 7.2, and all those frequencies, usually it will give you the harmonic of your crystal or your transmitter. If maybe, I don't know, maybe you're using some sort of VFO or something, but that's the idea. So a filter that is good, well calculated, it will eliminate these harmonics that you might have, so you won't be able to hear them during transmit. You will only hear the fundamental frequency, because remember, for example, you're going to call CQ on 40 meters band, but you're not going to say, hey, CQ 40, CQ 40. You're just going to call CQ, CQ, and then you're going to put your call sign. If you don't have a properly made filter, somebody else, for example, on 14.4 megahertz, might hear that thing, and poor guy will try to answer back to your CQ call, but you won't be able to hear it because you're on 7.2 megahertz, and then he will wonder why you're not answering. So basically what you're doing, you're just creating interferences on another band while you're transmitting on the 40 meters band, not on 20 meters band. I hope this is very easy to understand for beginners. You know, it's a very rudimentary drawing, but I hope you get the idea. Alright, so that's the importance of the low pass filter, or some sort of band pass filter in my case over here, when building any kind of transmitters or transceivers. Let's say, because I had other people tell me that, oh, I built, where is it? I don't know where I put it, but I had my small transmitter. Let me find it. So I have this tiny 40 meters band transmitter, and they said, oh, I didn't have the crystal for 7 megahertz, I used 12 megahertz. Okay, well, the low pass filter on the output is not calculated for 12 megahertz, it's calculated for 7 megahertz. So of course this one will have to be recalculated for the frequency that you're trying to use. Now remember, okay, I understand that you might want to build and test transmitters and transceivers. It's very important that you transmit again into a dummy load, because you know, some people pick frequencies that are out of the amateur radio bands, and also they don't have a license to transmit anyway on any of the bands. So yeah, for that reason the dummy load is very important, again because we don't want to bother traffic happening on the radio bands. So stay legal, don't do illegal things. Alright, so again, let's say we're going to build a transmitter on the 40 meters band, which by miracle, by replacing the crystal on 14 megahertz, for example, on the 20 meters band, it will also work over there. But then, of course, your low pass filter won't work anymore. And because of that, because this one, the one that you had was calculated for the 40 meters band, the power output of your transmitter will be very low, because it's supposed to cut frequencies that are actually higher than 7 megahertz. So in order for this to work and to get the optimum power output of your transmitter, you will have to recalculate this filter for the 20 meters band, and then you will get a proper power output, and of course it will cut again the frequencies that are actually harmonics of the frequency that you're using. So that is the importance of low pass filters and band pass filters. You can't just replace a crystal, change the frequency of the transmitter to another band, but then everything else stays the same. So it's very important that you also recalculate the output filter of your transmitter or transceiver. Okay, so I hope this is easy to understand and I hope it makes sense for those making the first steps. Remember, I'm not an expert either. I'm also still learning, especially when it comes to filter and tuning them properly, and without proper equipment it's kind of hard. But the idea is like this. For example, I will start transmit. I have the receiver here next to me. I did some tests earlier because that's usually my replacement for an oscilloscope or a tiny SA, where I can actually see the harmonic suppression of my filter and see how much it will cut the harmonics of the frequency of the fundamental frequency that I'm using. So the idea is that I'm supposed to hear very little or nothing at all if I transmit on 14.4 megahertz, for example. Actually, yeah, this is 7.02 megahertz, not 7.2 megahertz. But anyway, the idea is the same. But yeah, if I go on the 20 meters band, I'm not supposed to hear this one. Or if I hear it, it's supposed to be a very, very low signal. And that means the filter is doing its job. If I calculated the filter wrong, or I didn't build it properly, if I transmit on 40 meters band and I also hear it on the 20 meters band, then something is wrong with the filter. Of course, the filter is not doing its job because it's supposed to suppress those harmonics of the frequency of the crystal. So yeah, I hope it makes sense. But if it doesn't make sense, let me know, and probably I'll do a separate video just about filters, and I hope that one will explain things a little bit better and we can go a little bit deeper in theory. Meanwhile, I hope to get some tiny SA and do proper measurements for everything else. And by the way, for those that are building the Pititico, and if you have a way to measure the harmonic suppression, please let me know how good the filter works, because I'm very curious, and it's good to know if it does a good job or not. If not, then probably we'll have to improve the filter of this Pititico too. But I know that many of the people that built it just put a simple low pass filter on the output, a pi network filter similar to the one into the Pixie, and they were pretty okay with that one. So I hope this is the case for the Pititico too. Anyway, yeah, let's jump really quick on the receiver and do a demo about transmitting into a dummy load very close to the receiver, and then I'll move further away and let's see if we can still hear it. So we are onto the receiver. I'm going to raise the volume up, but I'm going to move the microphone close to the receiver in a little bit. I'm going to start transmitting very close to the receiver, so you will be able to hear the transmitter, and then I'll step away, but I won't have the microphone with me because I'll leave it here next to the receiver, so you'll be able to hear the signal. But as soon as I move away, probably you will hear a very, very weak signal or nothing at all into the receiver. and this is on 7 megahertz, so it's actually 7.02 megahertz, the frequency of the crystal of the Pititico. So this is a demo for the transmitting into a dummy load, close to the receiver and further away. Okay, let me put the mic really quick to the receiver. Alright, so sorry for the noisy receiver, but it's because of the LED lights. So as you can tell, as soon as I step away from the receiver with the transmitter, I transmit it from 2 points, about 2 meters away from the receiver and about 4 meters away from the receiver. And yeah, you don't hear anything. That's connected into a dummy load. If you connect it to a 2, 3, 4, 5 meters of wire as a dummy load, which is not a dummy load, then you'll be able to definitely hear the transceiver in that one. Now let's do a test about the filter, and we will transmit again. I will reconnect the battery. Okay, so now we're going to transmit on 7.02 megahertz. And now I'm going to leave the volume high. Alright, and now we're going to move to 14 megahertz. Let me change bands over here. And we're going to transmit again and see if we can hear it. You hear it? You can still hear it, but it's a very, very weak signal. I hear it at least. But the reason we don't hear it is because the filter is actually doing a good job, and it's suppressing those harmonics generated by the crystal oscillator. So that's the idea of a well-built and well-adjusted low-pass filter of your transmitter or transceiver. Alright, let's come back to the Pititico. So this is a Pititico 2. It's actually a design based off the original Pititico built by Miguel, Papa Yankee 2, Oscar Hotel. I believe I hope I didn't mess up the call sign. But it's nothing but a very simple Pititico. So it's basically a one transistor transceiver. But because it was hard for me to find the headphones that Miguel recommended for the transceiver, it was like high impedance headphones, but something like 300-600 ohms. I decided to build an audio amplifier incorporated into the transceiver so I can use regular headphones. And it's basically half of a Pixie, to say like this. It works fantastic. The transistor is overheating a little bit, but probably if you could use a metal can 2N2222 and put some little heatsink on top, maybe that one will be a little bit better. But yeah, it works fantastic. You can get about 700 milliwatts output power out of it, and even on receive it works really great. It's basically as good as a Pixie, except that it's a lot simpler and it's easier to build and you don't use so many components. Now the only disadvantage on this one is that adjusting the offset frequency it's a little bit harder. But yeah, I explain a lot more about this into the older video that I had and that I posted, and of course there's a little bit more explained into the blog article. But anyway, don't forget, you can order these boards from the straight from the article. I have them posted on PCBWay on my projects, and yeah, you can build it and have fun with it. I'm going to try to build a couple of these and send them to some of my friends, and we'll see. Hopefully I get to learn Morse code as well, and use get on air using CW, and have some fun doing QSOs with this tiny transceiver. So anyway, thanks for watching. I hope this video was helpful, and I hope it made you understand a couple of things about filters and dummy loads, and I guess I'll see you next week with another video. Until then, thank you again for watching, and 73.